Atomic mass versus atomic weight. Atomic mass is the equivalent of protons and neutrons of a specific isotope. Atomic weight is the average mass number between two or more isotopes. According to Avogadro's number, 1 mole is equivalent to 6.02 times 10 to the 23rd particles. So, to understand better Avogadro's number and its relation to atomic mass and atomic weight, we have to understand that Avogadro's number is known as also Avogadro's constant. It's a fundamental constant in chemistry that helps bridge the microscopic and macroscopic world because it tells us exactly how many particles, so how many atoms, how many molecules, how many ions, how many particles are there in 1 mole of a substance. This is the value of Avogadro's number. And now let's try to connect it with atomic mass and atomic weight. So first, let's look at atomic mass and atomic weight. The atomic mass of an element is usually measured in AMU, which is atomic mass unit, or U, just unified atomic mass unit. 1 AMU is defined as 1/12th mass of a carbon-12 atom, which is approximately 1.66 times 10 to the negative 26 kilogram. Referring to atomic weight, which is also known as relative atomic mass, it's the weighted average of the masses of all the naturally occurring isotopes of an element based on their abundance. It is dimensionless, meaning it has no units, and it's typically listed on the periodic table. So let's go ahead and use an example. So I'd like to use carbon first, or as an example. So remember that we have carbon as an example. So regarding the atomic mass of carbon, atomic mass versus atomic weight. It's important to understand that atomic mass is when you add the protons and the neutrons of a specific isotope. So isotope, remember, is just same proton, different amount of neutron. Atomic weight is the average mass number between two or more isotopes. It's based on the Avogadro's number. This is the Avogadro's constant, Avogadro's number, same thing, can be used interchangeably. It is a fundamental constant in chemistry that helps bridge microscopic and macroscopic world together. It tells us exactly how many particles are there in 1 mole of a substance. So how many atoms are there, how many molecules are there, how many ions are there, etc. The atomic mass of an element, as stated a while ago, is measured in atomic mass units, AMU, or unified atomic mass units. One atomic mass unit is defined as 1/12th mass of a carbon-12 atom, while atomic weight is also known as relative atomic mass. It's the weighted average of the masses of all the naturally occurring isotopes of an element based on their abundance. It is dimensionless, which means it has no units, and it's typically listed on the periodic table. So let's go ahead and try to relate Avogadro's number to atomic mass and atomic weight. So we have here 1 mole. 1 mole is equivalent to Avogadro's number. So 1 mole of an element is always equivalent to 6.022 times 10 to the 23rd atoms. So this tells us that in 1 mole of an element, we have this much atoms in it. Remember that the mass of an element in grams is equivalent to the atomic mass of the element in AMU. So, with that in mind, let's go ahead and give an example. So, for example 1, we'll have carbon. So, we have carbon here as our number 1. The atomic mass of carbon is 12. So we put 12 AMU. So if there's 12 AMUs, and we know that 1 AMU is equal to 1 gram, we know that 1 mole of carbon atoms weighs 12 grams. This means that 12 grams of carbon contains exactly this amount of particles, which is based on the Avogadro's number. Now let's use an example for oxygen. So oxygen has 16 AMUs. 1 mole of oxygen is equivalent to 16 grams. Since again, 1 gram is equal to 1 AMU. In this case, this means that in 16 grams of oxygen, there's exactly this amount of particles.